matrix inversion method. Now, in this matrix inversion method, so we have this set of equations. If we remember, our set of simultaneous equations are a11 x1, a12 x2 plus a13 x3 equal to b1, a21 x1 plus a22 x2 plus a23 x3 is equal to b2, and a31 x1 plus a32 x2 plus a33 x3 is equal to b3. Now this we write in matrix form as matrix of the coefficients so these are the coefficients of the unknowns. This forms a matrix, then a column matrix or the column vector of the unknowns. So is equal to the column vector of the constants. So we write this is A, this is X, and this is B. We know that. So we have the equation A into X equal to B. And if we want to find the solution, if determinant of A is not equal to 0, then A inverse exists. For non-singular matrices, singular matrix means when determinant of A is equal to 0, it is singular matrix. And when determinant of A is not equal to 0, it's non-singular matrix. For non-singular matrices, inverse exists. Adjoint A by determinant of A. That is the inverse. So A inverse exists, and A inverse is equal to adjoint A upon det A. And we know from the rules of Cramer's rule we have studied and ranks we have studied. If determinant of A is not equal to 0, the system will have a unique solution. System has a unique solution. All right. Okay. Now let's proceed further from here. So AX is equal to B and AX is equal to B and determinant of A is not equal to 0. That means inverse exists. So then what do we do? Multiply throughout with A inverse. So if we do that, A inverse into A times X is equal to A inverse B. This will be I times X is equal to A inverse B. So X is A inverse B. Straight away we get this. Okay, so we solve the equation like this. So let's take an example on this. Okay, solve the following system of equations. So we have 3x plus 4y plus 5z is equal to 18. Then 2x minus y plus 8z is equal to 13. Then 5x minus 2y plus 7z is equal to 20. So we will use matrix inversion method.
Three, four, five.
Good.
5,
3, 4, 5. Good. Next line.
2 minus 1, 8,
2 minus 1, 8. Very good.
5 minus 2, 7.
Very good. So this is A. A times the unknowns are X, Y, Z, and the constants are 18, 13, 20. Yeah, 18, 13, 20. So now we reduced the given equations into this form. So this is A, this is X, and this is B. So X, we know, is simply A inverse B. So we have to find A inverse. So finding A inverse. So how do you find A inverse? A inverse is adjoint A upon determinant of A. So what do we do? How do you find the adjoint? From A, we find the cofactors of the elements of A. And from there, we find the adjoint, and also we find the determinant. Once you find the cofactors, we'll find the determinant, and adjoint A by determinant A will give us the inverse. Okay. So this is the steps involved. So this is A for us. 3, 4, 5, 2 minus 1, 8, 5 minus 2, 7. Okay, now please participate. Now you please tell me this is A. Okay, I want cofactors of A. That means I'm replacing all the elements by their respective cofactors. So what is the cofactor of the first element? 3.
9.
Yeah, it is minus 7 minus of minus 16. So minus 7 plus 16 is 9. Correct. Cofactor of the second element?
Minus 26.
Very good. Eliminate the first row, first column, first row, second column. Then you're left with 2, 8, 5, 7. 2 into 7, 14, minus 40, that is minus 26. Minus 26 with a minus sign. Acha. Cofactor is minus of 1 to the power I plus j into minor. So minor is 14 minus 40, that is minus 26. So minus of minus 26 will be plus 26. So you have to be very careful with the sign. Next, cofactor of 5.
1.
1.
Okay. Eliminate first row, last column. Minus 4 minus of minus 5. So minus 4 plus 5, 1. And the sign associated for this space is plus. So plus 1. Then next, for 2, this element 2, second row, first column element, cofactor.
38.
38, very good. 4, you eliminate the first column and the second row. So you're left with 20, 4 sevens, 28, minus of minus 10. Good. 38, but with a minus
Yes.
sign. Very important. Next. The middle element, minus 1. What are the cofactors? What is the cofactor?
11.
Good. No, not 11. You have 3, 5, 5, 7. 3 sevens, 21, minus 25.
Minus 4.
Minus 4. Minus 4. Then 8, cofactor of 8. Minus 6, minus 10. So minus 16. Sorry, minus 26. Minus 6 and minus 20. So 3, 4, 5, minus 2 are left. So minus 6, minus 20. So minus 26. Minus 26 with a minus sign, you get plus 26. Okay. Next. For 5,
37.
37. Very good. For minus 2,
Minus 14.
Minus 14.
minus 14. 24 minus 10 is 14, but with a minus sign, minus 14. And for the last element,
Minus 11.
minus 11. Correct. Minus 3, minus 8, minus 11. So this is our matrix A. This is the cofactors of A. Now, adjoint of A. What is adjoint of A? Transpose of the cofactor matrix. Transpose of this matrix. So you get 9, 26, 1, minus 38, minus 4, plus 26, and then 37, minus 14, minus 11. This is the adjoint. Okay. Now, A, cofactor A, adjoint A. How do you find the determinant of A? How do you find the determinant of A?
First row of matrix A into first row of cofactors.
Very good.
Summation.
Very good. Elements of the matrix along any row multiplied by their own cofactors and then take the sum of them. So take this first row, multiply with their own cofactors and sum them. So you get 3 into 9 plus 4 into 26 plus 5 into 1. So you have 27 plus 104 plus 5. How much is this? 136, right? 104, 25, 27 plus 5, 32 plus 4, 36. So this is 136. This is the determinant. So we found the determinant, we found the adjoint. Now what do we have to find? A inverse. So X is A inverse times B, and A inverse is 1 by det A into adjoint A times B. So it is 1 by 36, 1 upon 36, 1 upon 136 into adjoint 9 minus 38, 37 26 minus 4 minus 14, 1, 26 minus 11 multiplied by, what is the matrix B? 18, 13, 20. (18, 13, 20), correct. So now let's do this calculation. Product. This is 3 by 1, sorry, 3 by 3, and this is 3 by 1. So the product will be a column vector. So 1 by 136 times. So 9 into 18. How much will that be? Please calculate and tell. Somebody can calculate this and tell. You get 9 into 18. Then minus 38 into 13 plus 37 into 20. Please do this calculation, someone, and do this and tell me. In GATE exam, you will not be allowed to calculate, to carry your own calculators. So two methods. One is you have to be very fast in your calculation, or you will have to be good at using the digital calculator provided by them. Are you able to see the calculator?
Yes, sir.
Okay. So we have 18 into 9. 162. 37 into so plus 37 into 20 minus the second term 38 into 30. You get 408. So 1 by 136, 408. Okay, next 26 into 18 minus 4 into 13, 52. Okay, minus 14 into 2, 280. 14 into, sorry, 20, 280. So this is 136. And last one, I'm sorry, this is plus. The second term is plus. I missed it. So we have 18 plus 26 into 13 plus, oh, okay, minus 11 into 20. So again 136 and 408. 36 into 3 is 108. So 136 divides 408 3 times. So X value we get is 311. 311. So this is our solution. This is our solution. 311. Finding this is by matrix inversion method. Matrix inversion method. So we get this solution 311. We can cross check. You substitute 311. 3 in the first equation. 311. If we substitute 3 into 3, 9. plus 4 plus 5. So 9 plus 4 plus 5 is 18. So it solves. So it satisfies all the three equations. We can check and see 3, 1, 1. So this is the method of matrix inversion. So find A inverse and then multiply with B. Interesting thing, if you have 2 by 2, note this is from tip from for the objectives. If it is 2 by 2 matrix, if A is A, B, C, D, then A inverse, you should just remember this is 1 by AD minus BC. This is AD minus BC is nothing but your determinant. 1 by AD minus BC times D, D and A. So diagonal elements gets reversed, minus B minus C. This is your adjoint matrix and this is the determinant in the denominator. But we can remember this 1 by AD minus BC, D minus B minus CA. This will be the inverse. We can solve very fast. We just write A inverse like this and multiply with the constant vector and we solve the equation. Very fast, you can do that.